Hello everyone, welcome to this week's video. We are going to be discussing software testing techniques. This is part of our software testing techniques course number 2, where we are going to be doing a deep dive and learning some hands-on applications of some of the concepts we have learned before. So software testing techniques. So this week really we are going to be talking about testing techniques. Last week we saw about like static testing and static analysis tool. Here we are going to be focusing on test techniques. Why do we need testing techniques? What is the point of testing techniques and what are we trying to accomplish using testing techniques? Here's the thing. Let us say that there is no approach to testing. We just like test what we want randomly. There are two problems, okay? So it is like a range. So if this is like the middle, so you could like do like very less testing, which would be under testing, and this could be too much testing. Okay, are we overdoing or underdoing testing? How do we know, right? So let us say that we are overdoing testing. What is the downside of that? If we are like testing too many conditions, we are putting in too much effort, the cost will go up, right? Time will go up because we are spending time on a task that is really not required to be spending time on, and that always like cost and time is a big no. Let's think about under testing. So this is over testing, under testing. So here we are like shrinking testing, so which means it's not going to meet its requirement, which means we are going to be at a risk, is going to increase, quality is going to decrease, right? Because we don't test enough. So we have to be able to find that sweet spot somewhere in between. Okay, how do we find that sweet spot where we are doing enough testing and we are not like overdoing or underdoing our testing, but we are doing just the right amount of testing. So in order for us to be able to know how much testing is good, how much testing is enough, how much testing is required to minimize and mitigate our risks, that is where we use our testing techniques. So when we talk about software testing techniques, we always want to like think about black box and white box testing, white box and black box. Okay, so white box is where we actually know how the code is implemented. We provide an input, we get an output. So whatever input we are providing, the testing technique is going to be based upon the implementation details. We know how it is done. Okay, so we already know the answer, and that's what we are going to be using to create our test conditions on. In terms of black box testing, we do not know what is inside. Nobody knows what is inside, like the tester doesn't know. So we provide an input, we get an output. Okay, how are we doing this? How do we know how it's supposed to behave? We are going to be using the user requirement in order to craft our test conditions. Okay, so here in the white box testing, for our test conditions, we are going to not only take the user requirements, we are also going to be like sitting through the design reviews, code reviews, user requirement specification reviews, all these reviews, looking at the code, having an idea how it is implemented. We kind of know the vulnerabilities already that we want to quickly like touch upon to see how it will hold up. And that is what white box testing is. Last week we saw the static testing analysis using tools, and there's a little bit more on that topic. Now we are going to be looking at black box testing. So in black box testing, you have to remember we don't know how code is. Okay, we do not know. Or rather than saying how code is, let us say how the logic has been implemented. We do not know how the logic has been implemented. Okay, we have no idea. Okay, we do know, the only thing we do know user requirements. That is all we know. So we are going to be basing everything off of the user requirement, and we are going to assume that this is a black box. We are not going to worry about the implementations inside, but we are just going to move on. Okay, so in black box there are multiple techniques that we can use. Today we are going to be using two techniques. Okay, they are going to be called as equivalence partition, and then we are going to be using boundary value analysis. These sound really scary, right? But they are not. They are like really simple. We are already using them. Inadvertently we are using them anyways in our everyday life. For so many scenarios we tend to do this naturally. So there is nothing scary about it. Okay, let's look at one example. Let us say that in Cleveland, Playhouse Square, there is some concert or some kind of show that is going on. So let us say there is some kind of concert. The ticket price is 100. But then the concert people have announced that the following structure to their tickets. Okay, so they are saying under 2, free. Okay, if somebody is over 67, they only have to pay 15% of the cost. They also want to make like a really nice break for tweens, right? Under 13, they get a 25% cost. Let's make it 10%. They are getting it for 10%. So if the attendee is under 18, they only have to pay 25% cost, like student discount. Everybody else gets to pay $100. Let us say that this is how the concert people want to sell their tickets, and let us say this is going to be implemented as a logic. So you can already tell that there are the logic is in segments, right? So we have the general category, then we have the under 2, then we have the over 67, under 13. So we have 1, 2, 3, 4, 5 categories already. Okay, so what do I mean by categories? Okay, anyone under the age of 2, right? If you are 1 year old, 2 year old, under age of 2, right? So if you are like 1 year old, or if you are just born, if the baby is just born, 6 months old, it's going to be, it doesn't matter. The child will not have to pay for any money for that. The child will not be charged for that fee, right? So that's what they're saying. Again, there's somebody that's over 67. So you could be 68, 69, 70, 71, 72, blah, 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 right? You're going to still be only paying 15% of the cost. So we are kind of grouping. Okay, we are going to be grouping data in such a way that we don't have to test every single data point, as long as we test something in that segment 1, segment 2, segment 3, segment 4, segment 5. So if we have 1, 2, 3, 4, 5 segments, if you test like one data point from that segment or partition, that is good enough. You don't have to test every single value. So that is the logic there. Okay, So let us do our partition here. So let us look at our partition here. So under 2, right? So this is the partition number 1, 2, 3, 4, 5. Okay, these are the partitions. Under 2, right? Then over 67, under 13, under 18, and then we have the general category, right? So let's rewrite this now. Under 13 means what? From the age 3 to age 12, right? 3 to 12. Under 18 means 13 to 17. And here it is 18 to 67. And then this is going to be 67 to, okay, I left it blank on purpose. Here when we say under 2, we are going to be saying 0 to 2. 0 means like child could be 1 month, 2 month, 3 month, right? Okay, so this is going to be called as partitions. These are all valid partitions. Okay, give me a second here. Okay, so all the data inside, let us say this partition, is going to be having the same behavior, same like this one, same like this one. They are the only then they can be a partition, otherwise it doesn't make any sense. Same here and same here, right? So what does that mean is, instead of testing all the values that are possible for age, we will test one particular value, could be anything in that range, from each and every partition. So I wrote valid partition. So are there invalid partition? Yes, of course, there are invalid partitions. Let's talk about them. So here, what happens if it's not, if it's under 0, is that valid? So negative is invalid because age cannot be negative. On this side, what do we have? What is the upper limit for age? Let us say, and we can always like verify this with our business folk. Maybe we are saying up to 100 is when this particular concert program is supposed to work. 67 to 100. So if they are going to be greater than 100, then that is going to be an error. Okay, so I'm just like making an assumption here. What is going to happen? What is the output? Error. Okay, so what is the output here? Error. Okay, for the rest of them, so if you think about, this is the input, this is the output. Okay, so let's write the output separately. I don't want to like write it inside this table. Let me just clean this up a little bit. Okay, so now let's look at our partitions. So when you like do your lab, you want to make sure that you're coming up with this partition and clearly like labeling the valid partitions, and then you're going to be, instead of putting this arrow, just leave it like that, lower end, upper end, and that's good enough. Okay, so there is a lower boundary value, upper boundary value, right? So what happens is, from each of this category we have to pick one value as input, right? Age equal to, we have to make sure that we are picking one value from each category. Okay, so negative means I can give -1, Between 0 and 2 I can give value as 1. 3 and 12 I can give it as 8. It doesn't matter what we give as long as it's in that range. And then greater than 100 I'm going to give 101. Okay, so this is the test case. These are the test cases. So we have 7 test conditions, right? Age equal to -1, age is 1, age is 8, age is 15, 24, 98, 101. Why I picked 98? Because it doesn't matter. It should be between 67 and 100. That's it. So I chose 98. You can choose whatever you want. And it's still not going to compromise the quality of the test as long as they are falling inside that particular partition. Okay, so for okay, for equivalence partition, we have 7 test cases. When we test those 7 test cases, we are going to make sure that every single segment got tested, including the valid and the invalid. Okay, cool. So what are we talking about in terms of the boundary value analysis? The name implies it, right? Boundaries. So equivalence partitioning and boundary value analysis go hand in hand. Okay, so one thing can yield to another. So the concept of equivalence partitioning is to test one value from each partition. The concept of the boundary value analysis is to make sure that all these boundaries are tested. You want to make sure that you're testing for all these boundaries. That is the purpose. So they are not mutually exclusive. They complement each other. So let's think about it. Well, what does this mean? If I talk about like boundary value, I am saying I have to test for 0, 2, 3, 12, 13, 17, 18, 67. Oh, see, there is 67 in 2 areas. I'm wrong. So this is wrong. This is 68. See, that helps us find out problems. And then in terms of the invalid values, we just go like one behind, and this will be 101. Okay, you can see that sometimes there is an overlap, okay, between equal value equivalence partitioning and boundary value, right? This and this are like overlapping, and that is okay. Okay, you don't have to like do them twice. You just do them in one spot. It's the same test. You expect the same output, so it's fine. So because they seem to have the same value, we could just cut this out. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here I have 1, 2, 3, 4, 5, 6, 7. So I have 10 here, 7 here, 10 here. Okay. But if they are unique, okay, so then the concept is in boundary value for each partition there will be 2 boundary values, minimum and maximum. They both have to be tested. And then one from the invalid, the immediate value in the invalid, invalid will have a range, right? So the immediate value before the first valid value. So this is 0 means the immediate value before that, and then the immediate value after the maximum of the last partition. So we have to make sure that we do that. So now that I said that, I also have to remember that there are some variations to this that has been listed in your book. I don't want to go into it too much, but I just be assured that we are doing like 10 plus 7, 17 test cases. Instead of randomly picking some data, we are thinking about it and doing it in a way that makes sense, and that is going to reduce our risk and also keep our cost low. So when you write your test cases, you will make sure that you have these ages considered, and then you're going to be looking at the output to make sure that it meets the criteria. So this is how you will be creating your test conditions. These test conditions can test it can be user acceptance or system testing or interface testing or component testing, it doesn't matter. A technique can be applied to any type of test plan, test condition. Okay, so these are the two: equivalence partitioning and boundary value analysis. And I hope you enjoyed this video, and I hope it was useful to you. I will see you with more techniques under the black box techniques next week. Thanks.